to the Journée Chez Chem. Well, please do the 2 warm-up questions to the best of your ability, and we'll discuss them in a moment. Number 1, we are reviewing our periodic trends. And the very first question is asking about atomic size. Well, atomic size is the same as the atomic radius. And we look at the snowman. And the snowman is big on the bottom, and he always falls over in this direction. And therefore, when we look at these elements, we see that we're going across a period. And therefore, the smallest one will be the sulfur. Then the largest atomic size, and I see that I'm going down the group. Therefore, I'm going down, and strontium would be the largest. The least amount of attraction for an electron affinity. Well, here we have silicon, phosphorus, and sulfur. Now, we're in the bin exception, and it's going to be phosphorus because phosphorus is S2P3 as compared to S2P4. When we look at S2P3, the phosphorus, we have S2 and we have the 2 electrons in the S sublevel, and we have 1 in each one of the P's in that sublevel. There are 3 p orbitals, and each one is spinning in the same direction because you remember the school bus rule, we always have to put 1 electron per orbital before we go back and fill. Now this is a very, very stable and low energy configuration as compared to sulfur, which is S2 and P4, where we have that 1 extra electron there. And therefore, this phosphorus, does not have the same amount of attraction as the sulfur does for the electron. And therefore, our answer is phosphorus. Now, sometimes when you're asked to explain this, you can't say it's the bin exception. That's just a way, it's a tool for us to remember that we have those exceptions with electron affinity and ionization energy. But you must explain it using an orbital filling diagram or explaining about the electron spin. The next one here is the largest electronegativity. Well, electronegativity is a man-made scale, and so there are no exceptions, and therefore the answer to this would be the sulfur. And then we have ionization energy. The largest amount of ionization energy here would be the phosphorus for the same reason that was given above in the electron affinity. Then the largest ionization energy here would be the magnesium. Well, the magnesium is S2 as compared to an S2P1. This magnesium looks like this, and we compare it to the aluminum, which is S2 and P1, and therefore it's easy to remove this lone electron in that P sublevel, and therefore it takes more energy to remove this electron from this filled S orbital. And that is part of our bin exception. And you'll notice that I still have to draw the 3 lines for the 3 p orbitals, because just because someone's not in the home at night doesn't mean there's no house there. So we have to write those lines for those p orbitals. And that's how you do number 1. In number 2, we are determining which of these is the larger. Well, in the first case, I have magnesium, or the magnesium ion, that has a +2 charge. Well, that +2 charge is telling me that I lost 2 electrons. Well, when I lose weight or I lose electrons, I lose size, and therefore the larger is the magnesium. And I have to pay especially close attention to what the question is asking for. And that's why I wrote up there a little bit of a keyword to remind me of which direction I was going. Fluorine, or the fluoride ion. Well, the fluoride ion has gained 1 electron, and therefore it's gained size, and it must be the larger. In the next two, I'm going to take a look at the snowman to remind myself as to what happens with the atomic size as I go in a direction on the periodic chart. And when I do that, I see that I have my snowman, and he falls over to this side always. His little head goes to that side. And therefore, when I look at rubidium and potassium, I see the potassium is above the rubidium. And we know that it's not in this order on the periodic chart, but this is the direction in which it's going. And therefore, the larger would be the rubidium. Selenium or bromine, well, I'm going in this direction. And so selenium would be here and bromine would be there. And therefore the larger will be the selenium. Now you have a review worksheet to do. And this is your very first review worksheet. They're always 4 pages. So you're given the time in class to work on it as well as this evening. Get that done, and it's excellent review for the assessment. Well, there is one thing I want to tell you though. On the first section of that review sheet, you have a description, and it asks for a variety of different words. And number 1, we have not discussed a lot, but it is very important to understand that the modern theory that we use for electrons and atoms and structure is the quantum mechanical model. That's the model that we use for the atom now. And it's very, very interesting and very exciting that this is a new model and a new understanding of the way the atoms actually work. I know you do well. Just get to work, and I can't wait to see you tomorrow. Bye.